All right, so today we're in section 4.4, graphing linear equations in slope-intercept form. So you've already learned what slope-intercept form is. Y equals mx plus b. Y equals mx plus b. So today we're going to start breaking apart this formula and really learn what it means. We know that x and y stand for an ordered pair. If I plug in a value for x, it helps me solve for y. We know that m stands for the slope or the rate of change. And we know that b, okay, while we've talked about what it is, you're really going to learn how it can help you graph a linear equation. B stands for the y-intercept. All right, what does it mean for something to intercept something else? What does that mean? It means to, I heard it, to cross it. So this number at the end of the equation actually tells me where the line is going to cross the y-axis. All right, so that is going to give me a nice little shortcut to graphing a linear equation. So in example 1, now your graph is not in your notes, okay? So don't worry about the graph part, but I'm going to show you that part, okay? In example 1, I give you the formula, and here's why. You cannot identify the slope and y-intercept unless the equation is in slope-intercept form, okay? Meaning it follows the same pattern. So look up here. Do I have the same pattern? Y equals mx plus b. Yes. You say, well, I thought this was supposed to be a plus sign in front of the b. It doesn't mean it has to be positive. It just means the number is by itself, okay? So if it's in slope-intercept, I am ready to say m equals and b equals. I want you to go ahead and write that down in your notes. M equals, B equals, okay? These values will help you graph. There's no more XY table. You don't have to come up with your standard set of values. This replaces it. This is your alternate method, okay? So which number is substituted in for m in this equation? Which number? -4, okay? Now, -4 is only one number though. Technically, I need rise over run for my slope. So what can I put -4 over that would not change its value? And I can put it over 1. -4 over 1. The reason I put it over 1 is to remind me that I have rise over run, so you don't think it's a 0, okay? Now, which number is plugged in where b goes in your formula? Get the sign right, I heard it. -2 is where b was in the formula. So here's my rule, okay? So just watch up here on this one because you don't have a graph in your notes. My rule says that I can plot a point on my b value because remember what b means. This b, what does b stand for? The y-intercept. So at this y value, the line will cross. The line will cross the y-axis on that value. Now from that point, don't go back to 0. From that point, you can follow the slope of the line to get to the next point. So if it's -4, do you think you would go up 4 from that point or down 4 from that point? Down 4. So go down 4 and then over 1 and plot your next point. So 1, 2, 3, 4 and over 1. Now you can draw your line. You'll want to use your badge, okay? And put your arrows on the end. You'll use your badge in a minute in example 2. Like down to example 2, we're going to graph them in a minute. Okay? All right, look at the next example. Okay, all we're doing is identifying the slope and y-intercept. All right, but then I'm going to show you what it looks like on a graph. The first question you have to ask yourself, am I ready to say m equals b equals? Okay, what do I mean by that? is the equation in slope-intercept? Is it in slope-intercept? Is y by itself? Yes. Okay. So now, which number is in the place of m where m was in the formula? 3, but remember, how do we have to write it? 3 over 1. Okay? So 3 over 1, so I have the rise over the run. All right? Now, Sequest, which number is in the spot for b in the equation? -7. Very good. Okay? So remember what we said. B stands for what? What does B stand for? The y-intercept, where the line for sure is going to cross the y-axis. So I need to plot a point on -7. Okay? Now from that point, where does my slope tell me to go? Up 3 over 1. So that's what I'm going to do. You guys are about to do this on the next example. Up 1, 2, 3 over 1. Plot your point and draw your line straight through it. Okay? And that's how you graph a linear equation. Let me tell you this. If you had done a table of XY values, your line would be in the exact same spot. The exact same spot. You could have done your XY. What numbers would you plug in? -1, 0, and 2. Plug them in, get your number out. Your line is going to look the exact same. Okay? So this is just another method to do the same thing that you've already learned. Taylor?
So when it's like a negative, you would go left, like over left?
No, never go left. When it's negative, you go down.
No, like for the bottom, right?
The bottom number will never be negative. Run will never be negative. If there's a negative in there, we'll talk about that in a minute. If there's a negative in there, the negative goes with the rise. If there's 2 negatives, that cancels out and the slope is actually positive. So your denominator is never negative. If there is a negative, bump it up to the numerator because that means the rise.
You always go right.
You always go right. That's a great question, and I can almost put money on it. Somebody will make that mistake on the test because it's a really common mistake. Don't let that be you, okay? We never run backwards, okay? You have a question?
Oh, no.
Okay. Rome?
How do you get
2 over -4? We're just going to have to keep going. I mean, it'll be the same thing on these. All right? Try to pay attention. I think it's pretty easy to catch on. All right? So now let's look at these 2 equations. Okay? What is different about these 2 equations versus the first couple? Joy?
The y is not by itself.
The y is not by itself. So because of that, I'm not ready to say m equals b equals. I can't identify those values until y is by itself. It's in slope-intercept. Are you paying attention? Okay. So, all right, just to give you guys something familiar, I'm solving for y. What would I need to do to get y by itself? What would I need to do?
-5 will cancel out.
Okay, how do you move it?
Add 5.
Okay, you add 5 to both sides. So I'm going to add 5, and I'm going to add 5. All right? Now, can you add 3 over 2x plus 5? Can you just add them together? No, they're not like terms. But if I'm following slope-intercept form, which number comes first? Y'all tell me.
Negative, no, that's not.
It's 3 over 2x. I bring that term down first. Then do I bring down a plus 5 or a minus 5? Plus 5. Now is this equation in slope-intercept?
Yes.
So now you can say m equals and b equals. I want you to take a minute, write down your m and your b values, turn around to your neighbor and check your neighbor's work. Okay? Think to yourself, pair up with a neighbor, and share your answers. Okay, go ahead and do that. Okay, Zoe, what did you put for m? M equals 3 over 2. And Isaac, what did you put for your b value?
My b value?
Yep.
can I tell you like just the whole answer?
What is your B value?
+1.
No. What's your B value, guys?
5.
It is 5. Very good. Okay, so we're not graphing this. Pay attention. We're not graphing this. But if I was, where would my first point go on my graph? On a Y value of 5. Then where would I go from there? Up 3 over 2. Okay, I would follow my slope. All right, let's go ahead and do the next one. I'm going to be walking around to check on your papers. I want you to solve for Y and then write your M equals B equals. Okay, so when I'm walking around, I'm looking for your answers. M equals B equals. What did you guys do to get Y by itself? What did you guys do? +1 to both sides. Okay, looked really good as I was walking around. -2/3 X plus 1. So M equals, say it with me, -2 over 3. B equals 1. Okay, so if I were to graph this, where does my first point go?
On 1.
On a 1 on the y-axis. The y-intercept is 1. Then where would I go from there? Down 2 over 3. Down 2 over 3. All right, so now you guys get to put that to the test. Okay? On example 2, the first thing we need to do is say M equals B equals. Okay? I want you to write this down while we're still getting in the habit. Here's the great thing about graphing and slope-intercept. If it's already in slope-intercept, there's no math to do as long as you know what you're looking at. Okay? So is this equation in slope-intercept? Is it ready to graph? Yes. Okay? So I'm going to raise your hand and tell me, what is your M value? Braden Harris, what is your M value? -3 over 1. Okay? And let's see, Josh, what's your B value? 3. Okay? So because of that, all right, because of those values, Gavin, where would your first point go on your graph? Up to a Y value of 3. Because remember, B means the y-intercept. So that means this point crosses the y-axis at a value of 3. Where do I go from that point? Don't go back to 0. Where do I go from here? Where do I go from here? Let's see, Hope, Downing, where do I go from here? Or Hope Shepherd, either one. Down 3 over, you're fine. I shouldn't have put y'all back to back because I'm over there pointing at Hope and I'm pointing at both of you. All right, so down 3 over 1, okay? So just because it's negative doesn't mean I go backwards. It just means I go down. Down 3 over 1, plot my point, use your badge or a ruler, and draw your straight line through those points. The straight line is very important, okay? Because now it also asks me to identify the x-intercept. The only way to do this is to look at the graph and see where the line passes through the x-axis, okay? So the x-intercept, don't say x equals because that's not x, it's the x-intercept. What x value does the line cross the x-axis? An x value of 1. Does everybody see that the line passed the x-axis at a value of 1? Everybody see that? So your x-intercept is 1, where it passed the x-axis. Okay? All right, let's look at the next equation. What do you notice that's different about this equation versus the last one? Just tell me. It's not in slope-intercept form. So am I ready to say M equals B equals?
No.
What do you think, Jose? Am I ready? Paying attention? Okay. So I need to first solve for y. I need to solve for y first. What do? Y'all tell me. Come on. Just talk to me. Add 2 to both sides. Add 2 to both sides. So now y equals, what do I bring down next? Negative 2/3 x plus 2. All right. And now m equals and b equals. Noah, what do you think your m value is? What's your m value? Negative 2/3. Very good. Colin, what's your b value going to be? 2. Okay. All right. I want you to graph this line, and then I want you to tell me, okay, in your notes, what is the x-intercept. Once you have your answer, once you graph your line and answer that question, I want you to compare your answers with a neighbor. Okay, so you plot your point on a 2. And then you go down 2/3. So this one is similar because the point actually is on the x-axis. That doesn't always happen, guys. Sometimes you have to keep drawing the line to see where it's going to cross the x-axis. X-intercept is 3. X-intercept is 3. If you don't tell me the x-intercept, even if your graph is right, you're going to miss a couple points. Okay? Now let's talk about parallel lines. What do we know is true about parallel lines? They never cross. They never intersect. Okay? So in order for them to never cross, they must be sloping the exact same way. So lines are parallel if they have the same slope. Which value is my slope? M. My m value is my slope. So I need to see if my m values are the same. Now, am I ready to compare my slopes? Meaning, are these equations both in slope-intercept? Are they both ready? Yes, they're both in slope-intercept. So, are my slopes the same? Are my m values the same? Yes. So you will say, yes, they are parallel because, now, please listen to this part. You can't just say the slopes are the same. You have to tell me the value of the slope. So I know you know how to read it. Okay? You can guess and say the slopes are the same or the slopes are different. Tell me what the slope is. You're going to say both slopes are -3. So you're telling me that they're parallel, but you're also saying because I recognize that -3 is the slope on both lines. Are you paying attention? Paying attention? Okay. All right, look at the next one. Are you ready to compare your slopes? Yes. On the next set? Yes, because they're both in slope-intercept. Please stop. Okay, so now compare the slopes. Are your slopes the same? No. Are they the same? No. So you will say no because the slopes are 2 and -2. Again, you're not saying that they're different. If you say the word different, you're not getting full credit. Okay? Different, you can guess. If you say 2 and -2, I know you knew where to look to determine if they were parallel. Does that make sense? Okay? All right. Now let's look at the next one. This is what it's going to look like on a quiz or test. Okay? So can I just look at this and say, oh, the answer is no because this slope is -6 and this one's -3. The answer is no because one of them is not ready. Which one? Which one is not ready? The first one. Why is this equation not ready?
Because it's 3y, not just y.
Because it's 3y and not just y. Okay, so right now on your papers, before I tell you, sit up. Before I tell you, I want you to try to get y by itself. What do you need to do to get y by itself? All right, we're almost done. You guys can see we're getting close. Okay, What do I do across the whole equation? Y'all tell me. What do I do? Divide everything by 3. Because 3 is connected to y. Divide everything by 3. So y equals negative 2x plus 3. Now I can compare that to y equals negative 3x plus 3. Are these lines parallel?
No.
Why are they not parallel?
Because what is negative 2 worse than 1?
Okay, so tell me that. Because slopes are negative 2 and negative 3. Okay, so again, give me the slope values so I know you knew what to compare. Does that make sense? Okay, give me those values. They were not equal. All right, now we're going to take a little flashback here for a second. We're going to review slope. This is review, guys. So we learned this in our 2 lessons ago. 2 lessons ago. All right, to find slope with ordered pairs, what is my formula? Write it down right now. Hopefully we're getting close to 100% on this, guys. This is now your 3rd, maybe 4th exposure to this concept. Okay, so research shows 4 to 6 exposures to get to mastery. So some of you guys might need to see this 1 or 2 more times. Some of you already have it perfect. All right. What is my formula? Let's say it together. M equals y2 minus y1 over x2 minus x1. All right. Now let's say the sequence together. x1. What comes next? y1. Then x2, y2. Someone raise your hand and tell me, what would you subtract on top? Jada? 8 minus 10. Very good. All right. Bottom is a little trickier. Read me exactly how you would write it, Colin. Okay, he said plus 8. I'm going to write minus negative 8. Why did he say plus 8, though? Because the double negative. Did you guys catch the double negative? Those are going to be all over the place, okay? So you got to make sure you catch the double negative, make it a positive. What's 8 minus 10? Negative 2 over what's 6 plus 8? 14. Very good. Reduce it. Negative 1 over 7. Go, Talila. Go. Okay. All right. What is my formula? What's my formula when I'm trying to find slope on a graph? What's my formula? All right. Say a louder for the people in the back. Rise over run. Very good. M equals rise over run. Can I just pick any random spot? I actually can, okay? You can pick random points. However, you do want to make sure it evenly crosses the x and the y axis. So why not just pick the points that are already on the graph, okay? So count your rise over your run and reduce it. Go ahead and do that. All right, guys, what is it? Rise is what? 3 over 3 equals 1 over 1 or just 1. I technically prefer to leave it 1 over 1 because that reminds you rise over run. Okay, rise over run. So if you leave it in a fraction, that's actually a good thing because it reminds you rise over run. All right, how'd you guys do on that? Did you guys kind of remember what we had learned?
I didn't know whether the rise is negative.
Okay, from left to right is the line going up.
Oh.
As positive from left to right. If it's going down, it's negative. Okay, that's just going to take a little bit of practice. All right, so now I want you to draw an arrow. Okay, I want you to draw an arrow between the equations that are parallel to each other. There's going to be 2 sets. Okay, I want you to draw an arrow to the equations that are parallel. All right, go ahead and try to do that. This is the last thing for today.